We've done a lot of trig recently where we really needed our calculator. So when we were working with our right triangles and solving for an angle or a side, we were typing a lot of stuff into our calculator, and then we went to using non-right triangles and using our law of sines and cosines. We were typing stuff into calculators. In this lesson, we're going to be looking at some special angles that we can do trig for without a calculator. So in this lesson, we're going to be looking at specific special angles that we can evaluate trig for without the use of a calculator. And the first set of those special angles are going to come right from our axis lines. So yesterday we learned how to graph angles, and we learned that when we graph an angle, just went through a lot of slides, there we go. We graph it on our x and y axis. We learned that we start straight out to the right. So we talked about like opening a hinge, and if I don't open the hinge at all, then our angle is 0 degrees. If I open the hinge so it's pointing straight up, I'd be at 90. Wide open would be 180. Down at the bottom would be 370, or if I brought it all the way around, I would have gone around 360 degrees, or a full circle.
370?
360.
No, the bottom one.
The bottom is 270.
Yeah,
Okay.
I thought you said 370.
Yesterday we also learned another way to measure angles that was called radians. If I don't open my angle at all, I still have 0 radians. 0 is 0, like no matter what. 0 inches is 0 feet, is 0 miles, is 0 centimeters. It hasn't moved anywhere. Same thing with angles. 0 degrees is 0 radians. It's just nothing. Okay. What did we say a full circle was in radians?
2 pi.
2 pi. So then half of a circle would be
1 pi.
pi. What comes exactly halfway between 0 and 1 pi? A half of pi, and we're going to write that as pi divided by 2. And halfway between 1 pi and 2 pi would be 1.5 pi's, and we're going to write that as 3 pi over 2. These 4 axis lines are angles that we can define trig for without the use of a calculator. The way that we're going to do that is by creating a circle that we're going to call our unit circle. We're going to say this circle has a radius of 1, and that's why we call it a unit circle, because it has a radius of 1 unit. I did not draw that circle, no.
Should have said yes.
I don't want to lie. Sometimes I do like taking credit for things that I don't maybe have a right to take credit for, but I didn't draw that circle. What we're going to do now is label the 4 points where this circle intersects each of those axis lines like an algebra point, so like an x comma y. So in algebra you learn that a point is an x value then a y value. And x is a sideways movement and y is an up or down movement. So this point that's on our 0 line would have a sideways movement of 1 and an up movement of 0. The point that is up at the 90 line has a sideways movement of 0 and an up movement of 1. The point out at 180 moves to the left 1, so negative 1 and up 0. And the point down at the bottom at 270 moves sideways 0 and down 1, so negative 1 for down. So that's like algebra points, x comma y, where the first part tells us about moving sideways and the second part tells us about moving up or down. Having this picture drawn out is going to be extremely important, not only to being able to do your homework, but when it comes to the quiz next week, Tuesday, you will need to be able to draw this circle.
So like have
Okay.
memorized.
So, yeah, I mean, I don't think about memorizing, but yeah, I mean, you need to know how to create it. So if that means memorize too, then yes, I just kind of think about plotting the points. But now, this circle helps us find trig Because each one of those points defines two trig values. It defines a cosine of an angle and then a sine of an angle. That little symbol with the O and the line in it, that's the theta that we used before. That's just a way of saying an angle. So it has a cosine of an angle and a sine of an angle. It's alphabetical, just like x, comma, y, alphabetical, cosine, comma, sine, alphabetical, to help us remember which order they go in. Tangent is equal to sine divided by cosine. So when it comes to the quiz next week, having this picture memorized or being able to create this picture on your quiz paper to answer questions will be very important. So I'll give you a moment to get caught up on your picture if you need, and then we'll go on to an example.
So do we have to know the sign and cosine?
Yep.
It's not negative, so it's just that.
Alright, if you haven't gotten it all, you can grab it from somebody else. We'll go into an example. This question asks us to evaluate the 6 trig functions for our angle of 180. So I'm going to recreate the part of the picture that uses what this question asks about. You don't have to if you don't want to because you have the whole thing in front of you. But for this question, we're asked about 180 degrees. So that point on the 180 degree line was the one that was left 1, up 0. And we said that all of our points are going to be alphabetically cosine and then sine, and tangent is going to be sine divided by cosine. Okay, so you don't have to redraw this if you don't want to. For each specific example, you can just look back to the whole drawing, or if it helps you kind of narrow it down to what we're doing in the individual problems, then you can do that. Our first 3 trig functions are sine, cosine, and tangent. Sine, cosine, and tangent can never exist all by themselves. They need a number with them. It's kind of like a square root symbol. You can't just have a square root of nothing. You have to have a square root of a number. Okay? There has to be a number in there. Same thing with sine, cosine, and tangent. They can't exist all by themselves. They could be sine, cosine, or tangent of a number, and that number has to be an angle. So in this problem, we're talking about our sine, cosine, and tangent of 180. These values are going to come straight from that point on that picture. So that point represents the cosine and then the sine alphabetically. So the first part of that point is our cosine answer. So our cosine answer is -1, because -1 is the first part of that point. Then the sine is the second part of that point. So the sine is 0. And tangent is the sine answer divided by the cosine answer. And 0 divided by -1 is 0.
Why'd you say the 6 trig functions?
Good question. So we only did 3 trig functions here, sine, cosine, and tangent. And this question asks us to do the 6 trig functions. There are 3 more trig functions that we have not yet encountered. Okay? We have worked so far with sine, cosine, and tangent. There are 3 more trig functions that we haven't defined yet. They are the reciprocals of these first 3. What does reciprocal mean?
Second.
So like this and this.
One.
They're the opposite. So like sun.
Oh, so you're thinking about, I gotcha. I gotcha. No, for a number, what does reciprocal mean?
Like flipping it.
Flip it upside down. Okay, so reciprocal flips a number upside down, or flips a fraction upside down. These three other trig functions are called cosecant, which we abbreviate CSE,
What?
secant, which we abbreviate SEC, and cotangent, which we abbreviate COT. Cosecant, secant, and cotangent. These three are the reciprocals of the first three in the order that I have them matched up. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Usually students don't have a hard time matching up tangent and cotangent because those seem like they should go together. But often students will make a mistake in matching up the other ones because students will often want to put, for example, cosine with cosecant, wanting to match up those cos. But each pair needs a co. Okay? Think about it this way. You cannot have two co-pilots fly a plane. Somebody has to be in charge. You need a pilot and a co-pilot. Okay? You can't have two pilots fly because somebody has to be the one in charge. Okay? So each pair needs a co. So I need sine to go with cosecant. I need secant to go with cosine. So each pair has a plane trig name and a co-trig name. Okay? So reciprocal means flip it upside down. So we'll start down with tangent. And if I take that tangent answer and flip it upside down for cotangent, it becomes -1 over 0.
Undefined.
Which is undefined. Dividing by 0 is not allowed. It is like the biggest no-no in math. Okay, dividing by 0 is something we cannot do. So that is called undefined. For the other ones, they aren't fractions, but we can make anything we want into a fraction by dividing by 1. So I can just divide by 1 and now flip that upside down. Gives me 1 over 0, which again is undefined. We cannot do that. And for the cosine and secant, again I can just divide by 1. Flip that upside down and it becomes 1 over -1, which is still -1. When we do these reciprocals, an answer of 1 or -1 will stay a 1 or -1. An answer of 0 will become undefined when we flip it upside down. I don't think that we have this yet, so we're going to do another example. This one wants us to evaluate the 6 trig functions. For theta is pi halves. This time our angle is given in radians, but we do the problem exactly the same way. We're going to locate the pi halves in the circle, which is straight up or 90 degrees. That point is 0, 1. All of the points are cosine comma sine, and tangent is sine over cosine. So then our 6 trig functions, we want to find sine of pi halves, cosine of pi halves, tangent of pi halves, and then their new reciprocals, cosecant, secant, and tangent. Yeah.
Why did we do times 180 and the last one and times pi over half?
Oh, we're not multiplying.
Oh.
We're taking the sine, cosine, or tangent of that angle.
Yeah.
We're not multiplying by that angle, and it's just for whatever the question asked. So the last question asked for 180, this question asked for pi halves.
Okay.
So that'll be given to you as what angle to focus on.
That was the reciprocal.
We haven't done our fractions yet. It's the reciprocal of the
Oh, yeah.
answer. These are the questions. We haven't gotten to our answer yet. We'll flip over our answers. So to find the first three trig functions, sine, cosine, and tangent, we look to the point on the circle. That point gives us alphabetically first the cosine. So the cosine is going to be the first part of that point, which is 0. Then the sine will be the second part of that point, which is 1. Tangent is sine divided by cosine. 1 divided by 0. Which is 95. To find the other three, we're going to take the reciprocals of our first three answers. I can put anything I want over 1 to make it into a fraction. 1 over 1 is still 1 over 1. 1. If I put a 0 over 1 and flip that over, it becomes 1 over 0, which becomes undefined. And for cotangent, if I flip that fraction upside down, it becomes a 0 over 1, which becomes a 0. 1s or negative 1s will stay 1s or negative 1s. Undefined will become 0s, and 0s will become undefined. 1s or negative 1s will stay what they are. Undefined and 0s will go back and forth. Questions?
I don't get the, how you got the 1 over 1 and the sine of no.
Well, the purple one came from it being part of the point. So cosine comma sine, sine is the second value in that point. So the sine is the 1, because that's the second value in the point. Then I just put it over that blue one so that I could think about taking a reciprocal, because a reciprocal we need a fraction for. Okay. It is your turn to practice. This one's not on your notes, but I want you to take a few moments and practice finding the 6 trig functions for 270 degrees. For 270, I'm going to draw out just the part of the circle I need for that, which is the straight down line. And that point is over 0, down 1. All the points on the circle define the cosine and then the sine. And tangent is sine over cosine. Alphabetical, cosine, sine, just like alphabetical, x, y. So then our 6 trig functions, we want our sine, cosine, and tangent of 270. And then their reciprocals, cosecant, secant, and cotangent. Sine is the second part of the point, which for this point is negative 1. Cosine is the first part of the point, which for this point is 0. Tangent is sine divided by cosine, which has a 0 on the bottom, not allowed, so that is undefined. For the reciprocals, when you flip over a 1 or a negative 1, it will stay a 1 or a negative 1. When you flip over a 0, it will become undefined because it will put that 0 to the bottom of a fraction. And when you flip over an undefined, it will become a 0 because it will put that 0 to the top of the fraction.
So if you know that, you don't even have to like do the other side.
Right. If you know that, then you don't need to actually write out what the reciprocals are as fractions. You can just go straight to saying undefined or 0. Okay. Questions? One more thing we're going to look at today, which is easier. So, okay. It's easier partly because you've actually already done this. So yesterday we learned how to graph angles. And when we graphed an angle, there were a few parts to our graph. We used our x and y axis. We had our initial side, our final side, the arc that showed how we did it, and then the last piece of that was you needed to put a number in there that said how big you intended that angle to be. And I told you that that number should always be next to your x-axis. That number actually has a name. It's called the reference angle. So that number that you were putting into your graph pictures yesterday is the reference angle. So when these problems ask us to find the reference angle, really what they're asking us to do is graph and then find out what that little number is. 3 key characteristics of a reference angle. It must be acute. Okay, so that means between 0 and 90. I say a second key characteristic is it has to be positive. That's kind of a given with acute because acute is defined as being between 0 and 90, but I really want to emphasize it should be a positive number, not a negative number, even if the angle is going backwards. The angle still really needs to be a positive reference angle. And the third thing is it should always be graphed next to that closest horizontal line or closest x-axis. So to find a reference angle for 320, we're going to graph it. So we learned that to graph it, we start at our positive x-axis. We go around counterclockwise, 320 degrees, which gives me a value in that angle of 40, because 320 is 40 degrees before making it to the full circle. That 40 that you were putting into your problem yesterday is called a reference angle. So the reference angle here is 40 degrees.
That's it.
That's it. For radians, we'll want to graph that in radians. We learned yesterday that when we graph in radians, the denominator tells us how many pieces to cut each half into. So I'm going to cut the top into 6 pieces, and I'm going to cut the bottom into 6 pieces. So I need 12 pieces for my full circle. The denominator tells us how many pieces to cut each half into, because on the top of that fraction there's a pi, and pi is equal to 180, or half of a circle. So we're cutting that pi, or 180, or half of a circle, dividing that up by 6. The top tells us how many pieces to go around. So in this problem we have a -5, so we're going to start at our 0 line and go around backwards 5 pieces. And we land right here. Our reference angle is the value that should go in here, which is what in degrees? 30. We took 180, or half of a circle, and we divided it into 6 equal pieces. So 180 divided into 6 pieces, each of these pieces should be 30 degrees.
Use a calculator for that.
I would like you to not to, because when we come to the quiz, you won't have one. So 180 divided by 6, I hope you can do in your head. One more set of examples of this kind. So 140 in degrees. I start at my 0 line. I'm going to go around counterclockwise 140. And what is my reference angle? 40. It's 40 degrees before the 180. For the radians one, the denominator is 4. So we're going to cut each half of the circle into 4 pieces. 8 pieces total, like a pizza. Then the top tells us to go backwards 3 pieces. And this is our reference angle, which is 45. 180 divided by 4, or 90 divided by 2, gives us 45. I think the most difficult ones to do are when we're measuring with an odd denominator, so something like 2 pi over 3. Because I want to cut each half of the circle into 3 pieces, the vertical line is actually not helpful because an odd number doesn't have a perfect division for the middle. So if you're dividing into an odd number of pieces, you wouldn't want to draw on that y-axis. Then on this one I would go around 2 pieces, and my reference angle would be 60. 180 divided by 3.
Yeah, but it doesn't have to be drawn in scale, so you could just draw 3 lines.
It will be helpful to you if you can draw it somewhat to scale.
For the bottom right one, could you put the reference angle on the one where the arrow is, since they're both 45?
No, it needs to be next to the x-axis. That's a characteristic
Oh,
of reference angles. It
okay.
has to be next to the closest horizontal.
Okay.
You do not have any homework due tomorrow. From what we have learned today, you can do questions 1 through 4 on the next worksheet. And I would suggest that you do them so that when you get to it tomorrow, if you put it off, you're going to be like, how'd this happen? It's been, 2 days since I learned this. So if you do them tonight, it will probably go easier to just do questions 1 through 4, but we are not going to grade or collect those tomorrow. If you are missing any assignments, consider that your homework is getting yourself caught up so we can turn some of these grades around.